Problem 26, page 142. Two objects are connected by a light string that passes over a frictionless pulley, as in figure P5.26. Draw a free body diagram of both objects. I will draw the forces acting on M1. We have the weight, which is vertically downward. This is M1G. And we have the tension from the string, so this is T. The forces acting on M2 are the tension for sure. Tension is called the same as the tension, which is the tension acting on M1. كرمال we have a massless pulley. لما تكون البولي massless, التنشن من اليمين للبولي بيساوي التنشن to the left of the pulley. On M2 we have also the weight, which is vertically downward. It is M2G. We have the normal perpendicular to the support, and there is no friction because he said that it's a frictionless inclined. If the incline is frictionless, and if M1 equals 2 and M2 is equal to 6 and theta is equal to 55 degrees, find the acceleration of the objects. مثل ما حكيت قبل، إذا أنا عندي هيك نمط من الأسئلة, I have a pulley and two objects attached from both ends of a string. I usually apply Newton's second law to the first object, then I apply Newton's second law to the second object alone. I find two equations that contain tension and acceleration. I try to get rid of the tension and find the acceleration. So بحل كل object لحال، الأم1 لحال بجعل الأم2 لحال، وبدمج الإيكويشنز ليطلع معي acceleration. This is what I'm going to do. Before applying Newton's second law to each object, there's something important. I have to indicate the direction of motion of M1 and the direction of motion of M2 because I need to know the direction to project. دايما نحن بنعمل البروجكشن مع الدايركشن. البوزيتيف بيكون مع الموشن والنيجاتيف بيكون which is the force opposite to motion. So here I have M1 equals 2 kilogram and M2 is equal to 6 kilogram. So sometimes one will guess that M2 will pull M1, so M2 راح ينزل لتحت while M1 is going upward. So in our case M1 will go upward while the positive sense of M2 is downward along the inclined plane. So M2 will be moving like this. I will teach you how to know which object is going to pull the other. مثل هون إذا أنا عندي M1 وعندي M2, let me draw a figure aside. So I have this figure, I have my pulley, I have my object here. Okay, so I have my object here. In reality, the object M1, this is M1 and this is M2. The object M1, what's pushing M1 downward هي الويت تاعوله. So أنا في عندي الويت اللي هو M1G. هون مين pushing M2 downward? Pushing it مش الويت تاعوله, pushing it شقفة من الويت اللي هي M2G sine alpha. Okay, because M2G sine alpha is along the direction of motion. M2G مش كلها هي بتأثر على الموشن، لأنه M2G cosine alpha البارت اللي هو perpendicular للموشن هيدا ما بيأثر على الموشن. M2G sine alpha it is along the direction of motion, so it is responsible for pushing M2 downward. هلا أنا بقارن إذا M1G كانت أكبر من M2G sine alpha هيدا بيعني إنه M1 رح يشد M2. إذا M2G sin ألفا أكبر من M1G هيدا بيعني إنه M2 هي اللي رح تسحب M1. فهيك بعرف البوزيتيف سنس للموشن للأوبجكتس. في شغلة تاني for example إذا كان أنا عندي هون فنحن بحالتنا إذا بدكم case 1 I will write it. Case 1 we check مين أكبر. For example, نحن in our case we have M2G sine alpha is greater than M1G. So ما بيكفي بس يكونوا الماسز أكبر من بعض، يعني ما بيكفي يكون M2 أكبر من M1. لازم M2G sine alpha تكون أكبر من M1G لحتى يطلع أنا معي M2 is going to pull M1. ممكن ما يكون عندي inclined plane، يكون عندي السؤال بهالطريقة pulley string mass M1 from the other side another mass which is M2. On the force that's pulling M1 downward is its weight, so it's M1G. The force that's pulling M2 downward is its weight, it's M2G. Here in case 2 I have to compare M1G and M2G. Check who is bigger and then see if M1 will pull M2 or M2 will pull M1. ممكن كمان يكون عندي السؤال from both sides inclined plane. ممكن تكون هالinclined منا هي ذاتها بشكل انه هون انا عندي alpha 1 وهون انا عندي alpha 2 and the two blocks M1 and M2 rests on those inclined planes. This is M1, from the other side this is M2. The force that's pulling M1 downward is not the weight, هي ال portion of the weight that is with the motion. So هون اللي عم يشد ال M1 نزول هي ال M1 G sin alpha 1. اللي عم يشد ال M2 نزول هي مش كل ال M2G، هي M2G sin alpha 2. ليه؟ لأنه أنا عندي ال M2G cosine alpha 2 هيدي الفورس بتكون perpendicular مع الموشن. It does not affect the motion. So in this case I will write case 2 or case 3. We compare M1G sin alpha 1, we compare it with M2G sin alpha 2. Let us go back to our problem. We have to find the acceleration and the tension in part B. So قبل ما الاقي acceleration للسيستم I have to apply the Newton's second law for M1 and then I have to apply Newton's second law for M2. I will get two equations that contain A and T. I'll try to get rid of T and find the acceleration. عطول بنشتغل بهيك أسئلة بنفس النمط. So part A, first let's consider system M1. Consider system M1. Sum of F external, it's equal to M1A. What are the forces acting on M1? It's T plus M1G. It's equal to M1A. أنا معي الموشن للM1 upward, so باخد البوزيتيف سنس و upward. كل شي طلوع بيكون بلس، كل شي نزول بيكون ماينس، والvertical هو اللي بيساوي MA لأنه الموشن is along the vertical. So projecting I will get T minus M1G equals M1A. I will call this equation 1. This equation 1. I will find T from this equation لأنه راح أحتاجها تحت. So T it's equal to M1G plus M1A. هلأ بشتغل على system M2. So consider system M2. What are the forces acting on M2? There are three forces: tension, normal, and M2G the weight. These are equal to M2A. هون أنا عندي motion على inclined plane. راح أخد x axis نزول because the motion is downward. So this is x axis وال y axis بيكون perpendicular مع ال x axis. I will project along x axis and along y axis. Let's project back to the figure. بالنسبة لإلي N is along y axis, tension is along x axis. M2G I have to project it. So when I project M2G it will give me two components. One along x axis اللي هو M2G sin theta, والcomponent اللي هو along y axis is M2G cosine theta. Okay, so I will go back. مين في عندي على x axis؟ في عندي minus T plus M2G sin theta. It's minus T plus M2G sin theta equals M2A. كل شيء على x axis هون بيساوي MA، بينما اللي على y axis هن اللي بيساوي 0. So N minus M2G cosine theta is equal to 0. هلا ما كان في داعي للتاني projection along y axis. دايما بحتاج projection along y axis لما أكون أنا عندي friction، فأنا مضطرة ألاقي ال N. لما ألاقي ال N بستفيد منها بالF لأنه ال F equals mu N، بس هون ما عندي friction بالسؤال so I won't use it but I will project anyway. So I will call this equation 2. شو راح أعمل؟ راح أخد equation 2 حط فيها التنشن اللي لقيتها من equation 1 لأنه صار عندي 2 equations فيهم T وفيهم A. So من equation 2 راح أخدها راح أعوض فيها التنشن. I will get minus M1G minus M1A plus M2G sin theta equals M2A. لاحظوا صار معي equation فيها acceleration بس. I will arrange acceleration to one side. I will get minus M1G plus M2G sin theta equals M1A plus M2A. Now I will take A common. You can take A common. So minus M1G plus M2G sin theta equals M1 plus M2A. And now we can find the acceleration. It's equal to M2G sin theta minus M1G over M1 plus M2. We have everything. We have M1, we have M2, we have G, we have theta. We can substitute and you will get the answer 3.57 meter per second squared. This is the acceleration. هلا بمجرد ما الاقي انا الاكسلريشن I can find the tension. In part B بيقول لي the tension in the string we have to find T, so I can substitute يا بالequation 1 يا بالequation 2. I will choose to substitute in equation 1. So in part B, tension it's equal to M1G plus M1A. I have everything. You calculate it on your own. It will give me 26.7 Newton. بالpart C بيقلنا the speed of each object 2 seconds after being released from rest. أنا هيدي الأباراتوس كلها فلتها from rest، يعني V0 was 0. بما أنه طلعت معي الأكسلريشن constant فكل object is moving in uniformly accelerated rectilinear motion. هيداك الM1 is accelerating upward بينما الM2 is accelerating down the inclined plane. So the type of the motion is UARM. So I can use the kinematics equation of UARM. I will get V إذا أنا بدي استعمل بدي الفاينل speed. So I will get V equals AT plus V0. ال A هي ذاتها لاثنين objects because they are connected by an inextensible string. I have the time which is 2 seconds. I have the acceleration, it's 3.57. Time is 2, V0 was rest. So I will get my answer which is 7.14 meter per second. Okay, this is for V. I will add a part. هيدا البارت من عندي أنا. I will assume that there is a friction. Okay, and this friction forbids M2 from sliding down the inclined plane. So بهالحالة فعليا إذا بدكم الM1 عامل بالانس مع الM2 وما عم يسحطوا. فإن part B I say assume the inclined plane is rough. What must be the coefficient of static friction بدو الميو اس friction for the system to remain at rest. For the system to remain at rest. اوكي we have to find ميو اس. ليه سميها ميو اس؟ لانه انا اعتبرت انه الام2 بطل عم يصحى، صار عم يصير في نوع من الاكوليبريوم ما بين الام1 والام2. اوكي سو هلا هون صار في فريكشن، بدي ارجع انا حل السؤال من اول وجديد. بالنسبة للأم 1 ما تغير شيء لأنه هو كان معلق بالهواء. So M1 is not subjected to frictional force. رح تبقى معي أنا for M1 رح يبقى نفس الإيكويشن اللي كنت مطلعيتها أنا قبل، رح يطلع معي. هلا لما يكون at rest فيني اخذ البوزيتيف سنس مثل ما أنا بحب. ليه؟ لأنه هو at the end هو منه ماشي. So كيف ما أنا أخذت البوزيتيف سنس بالنهاية أنا رح أحطهم they are equal to 0, they are not equal to MA. So it won't matter إذا أنا أخذت البوزيتيف يمين أو بوزيتيف شمال. I'm just multiplying by a negative sign. والنيجاتيف sign if I'm equating to 0 it means nothing. Okay, so for M1 the sum of forces will be equal to 0. نعتبرهم at rest. I have only tension plus weight, they are equal to 0. So T minus M1G is equal to 0. I will get T equals M1G. Let's now do the same for M2. Sum of forces, because it is at rest, is equal to 0. Forces acting on 2 are normal, weight. في عندي الفريكشن اللي هي static friction because it is at rest, plus I have normal the tension, okay, which is all equal to 0. So projecting along x and along y will give me a 0 answer. مين في عندي على الاكس؟ في عندي على الاكس M2G sin alpha. في عندي بعكس الموشن minus static friction. في عندي minus t، هيدول كلهم بيساووا 0. اوكي، مين في عندي انا على الفيرتيكال؟ في عندي n minus M2G cosine alpha كمان is equal to 0. هلا if you can't imagine it I will draw it for you. هيدا inclined plane, this is particle 2. so هيدي M2G، هيدي N، هيدي tension والFR كمان لورا. so this is Fs, it's Fs the friction, static friction. كيف عملت projection؟ أخذت ال x axis downward, this is my x axis, and y axis is perpendicular to x axis, this is y axis. مثل ما شايفين ال n مع ال y، ال t مع ال x بعكس ال x axis, so minus t minus Fs مع ال x axis. ال M2G فيني أفصلها لشقفتين، شقفة مع ال x وشقفة مع ال y. The part that is with x axis is M2G sin alpha. إذا أنا بفصل if I project M2G along x and along y I will get M2G sin alpha plus M2G sin alpha ومع ال y minus M2G cosine alpha. So I will get these two equations. هلا أنا بدي لاقي الميو S. الميو S equals Fs over n, static friction over n. So I have to find Fs, it's easy. So mu S it's equal to Fs over n. From this equation مع ال Fs it's equal to M2G sin alpha minus t، عم حلها على السريع اوكي، over مع ال n من هاي equation second equation it's M2G cosine alpha. This is equal to tension كنت ملاقيتها it's M1G, so it's M2G sin alpha minus M1G over M2G cosine alpha. Okay, I can divide by G everywhere. هختزل على G، بيبقى معي M2 sin alpha minus M1 over M2 cosine alpha. I can divide by M2 cosine alpha لحتى أعمل الفورم أحلى. So I will get M2 sin alpha over M2 cosine alpha, it is tangent alpha, this is tangent alpha, minus M1 على M2 cosine alpha. So M1 over M2 cosine alpha. This is mu S, the static friction. Okay. Problem 44, page 144. Three objects are connected on the table as shown in figure P5.44. The table is rough and has a coefficient of kinetic friction of 0.35. The objects have masses of 4 kg, 1 kg, and 2 kg as shown, and the pulleys are frictionless. These pulleys are massless as well. So, in all our problems in this chapter, we are considering massless pulleys. أنا قلت قبل لما تكون البولي massless بيكونوا tensions from both sides of the pulley are equal. So, draw the free body diagrams of each of the objects. I have three objects. I will start with the first one, which is the 4 kg object. I will call it M1. So M1 equals 4 kg. I will call M2 equals 2 kg. And I will call the one on the table M3 equals 1 kg. The objects acting on the 4 kg object, which is M1. So I have the weight, which is vertically downward. It's M1. G, I have the tension, I will call it T1. Okay, what are the forces acting on M2? We have the weight, which is M2G, and we have the tension, it's called T2. ليه سميت هون T1 و T2؟ لأنه السترينج الموجود على يمين البلوك 1 غير السترينج الموجود على يمين على شمال البلوك 1. So this string I will color it with blue. هيدا string موصل من الM3 موصول لعند الM1 وكمان string تاني مش نفسه هو ذاته موصول من عند الM3 عند الM2. Okay, so you can see these are two different strings. بس يخلص string بلش string جديد, it's different tension. Same string, same tension as long as the pulley is massless. Okay? So, بالنسبة للبلوك اللي هو موجود على التيبل على الرف table, the forces acting on this block are the weight of this block, it's M3G, it's sitting on a table so it has a normal. التنشنز هيدي رح سميها T1 لأنه لنفس جهة T1. T1 and T1 are equal because it's the same string and the pulley is massless. With T2 they are equal because it's the same string from the right and the pulley is also massless. هلا بيبقى عندي الفريكشن كيف بدي ارسمها. بالنسبة للشيب اللي أنا عندي إياه it's obvious that the 4 أو ال M1G هي أكبر من M2G, so ال 4 رح يشد ال 2 kilogram object, so all the system will move this way. يعني ال 2 kilogram object will move upward. هيدا رح يروح هيك. This is the positive sense. أما 4 kilogram will move downward. So this is the positive sense. So because 1 kilogram object is moving to the left, أنا friction راح أرسمها هيك. So this is the friction. It is a kinetic friction لأنه ماشي. بس يكون in motion, it is a kinetic friction. So these are the forces acting on the object. Now, after drawing the free body diagram, I will find the acceleration of each object and the direction as well. So كيف بلاقي الاكسلريشن؟ مثل ما تعلمنا طبق نيوتن لكل واحد لحال. بيطلع معي هالمره فيهم تنشنز. عندي اثنين تنشنز T1 وعندي T2 لانه عندي اثنين strings. Okay, so I try to merge all the equations together. بالاخر يطلع انا عندي acceleration وحده اللي هي it's the same for all the three objects because they are all connected together. يعني نفس الحبل موصول نفس الدايركشن بس تمشي الM1 مسافة، الM2 والM3 بيمشوا نفس المسافة. So acceleration of 1 it's equal to acceleration of 2 it's equal to acceleration of 3. So I will call all of them A. Let me start first with M1. So consider M1. I will write here. Consider M1. What are the forces acting on M1? We have only two forces which are M1G plus T1 it's equal to M1A. كيف ماشي الأوبجكت downward؟ كل شيء لتحت بيكون plus ولفوق بيكون minus. So if I project M1G minus T1 كل شيء مع الY axis مع الموشن بيساوي MA. So it's equal to M1A. This is the first equation. Okay. Let me do for system 2. So consider system which is M2 كمان alone. بالنسبة لل M2 I have two forces acting on it, T2 plus M2G it's equal to M2A. لاحظوا ما بغير بتسمية ال A، كلهم A. ليه؟ لأنه كلهم they are moving with the same acceleration. لو ثابت عندي سؤال they are not moving with the same acceleration I have to say A1 vector, A2 vector like this. بالنسبة لل M2, M2 is moving upward. So the positive sense لإلي upward. بقول plus T2 minus M2G. So when I project I will say T2 minus M2G equals M2A. لاحظوا بتطلع بعكس ما أنا طلعت معي بالنسبة للM1 لأنه الM1 كان نازل بينما الM2 كان طالع. Let me do Newton's second law for M3. I'm solving بشكل مختصر لأنه صرت حالي منهم كتير so I don't like use Newton's second law apply سمنا ال F equals MA بعدين ال forces then project along X project along Y صاروا عاديين so I'm doing them in a rapid way. What are the forces acting on M3? عندي التنشن T1 عندي التنشن T2 عندي الكاينيتيك friction عندي ال N normal وعندي ال weight M3G. All these are equal to M3A. M3 was 1. Anyway هون بدي أعمل projection على X وعلى Y لأنه أنا عندي two dimensions عندي two directions of vectors. So البوزيتيف هو الهوريزونتال بس على الشمال. مين في عندي على الإكس axis؟ في عندي I will move down a little bit. So عندي plus T1 عندي minus T2 وعندي minus FK. هيدول بيساووا كل شيء على الإكس أو كل شيء مع الموشن بيساوي M3A. هي القاعدة كل شيء مع الموشن بيساوي MA ومحل ما في موشن بيساوي 0. أنا ما عندي موشن هون along Y so N minus M3G N minus M3G it's equal to 0. صار معي مثل ما شايفين هيدول ثلاثة أو 4 equations. I will make benefit of them and try to find the answer. هلأ هو بالسؤال معطيني الميو K so I will find N من هون بيطلع معي N equals M3G. راح اخد هيدي الايكويشن وراح اعوض فيها ال FK. So T1 minus T2 minus mu Kn equals M3A. I will call it 2. I will call it 3 equation 3. I will call this one equation 1 and I will call this one equation 2. So I will take equation 3 واشتغل فيها تحت شوي. So 3 will give me T1 minus T2 minus mu K M3G equals M3A. بعد بدي أعوض محل ال T1 وال T2 من وين بجيبون هيدول؟ من equations 1 and 2. So من equation 1 طلعوا فيها ال T1 بتساوي M1G minus M1A. عوض محل T1. هلا T2 من وين بجيبها؟ من equation 2. T2 بتساوي أنا I'm substituting them directly. This is T1 minus T2 was M2G plus M2A minus mu K M3G equals M3A. هلا شو بعمل؟ صار عندي equation ما فيها لا T1 ولا T2. بجمع الاكسلريشن نفس الجهة وبلاقي الاكسلريشن. Everything is given. I will arrange. عندي M1G عندي minus M2G عندي minus mu K M3G it's equal to باخد لهونيك عندي M1A plus M2A plus M3A اللي هي M1 plus M2 plus M3A. So I will take G common بصير شكلها أحلى. M1 minus M2 minus mu K M3G equals M1 plus M2 plus M3A. So we get A is equal to M1 minus M2 minus mu K M3 over this is M1 plus M2 sumless system M3 times G. Substituting all of this you will get it's equal 2.3 meters per second squared. أكيد الأم 1 معي إياها، الأم 2 معي إياها، ميو كي معي إياها. I have everything, substitute and you will get the answer. بالسؤال كمان بيقول لي in part B determine the tensions in the chords, in the two chords. بدي T1 وبدي أجيب T2. so part B, this is part B. كيف بجيب T1 من equation 1؟ أنا طلعت I will erase this one. so from equation 1 أنا كنت جايب T1، كانت T1 بتطلع معي M1G minus M1A. بعوض مع ال A ومع ال M1 ومع ال G 9.8. I substitute, I get T1 equals 30 نيوتن. بينما ال 2 يعني لاحظوا انه عم نحل كأنه system of unknowns، عم ندمج الايكويشنز سوا كرمال نخلص من التنشن ونجيب ال A، بعدين بنرجع بنجيب التنشن. so T2 بس تصير معنا ال A بصير فينا نجيب التنشن. so it was equal to T2 was equal to M2G plus M2A. ومعنا كل شيء، معنا ال M2 معنا ال acceleration. we will get 24.2 Newton. This is for problem 44. I will do now problem 55. In problem 55, it's a different problem, but it's good anyway. An object of mass M is held in place by an applied force F and a pulley system as shown in figure P55.5. The pulleys are massless and frictionless. So our pulleys are massless. Find the tension in each section of the rope T1, T2, T3, T4 and T5. We have to find the tension in each of them and the magnitude of F, which is the force, okay, that's being applied to the system, which is holding M. So F is holding M. So this system is at rest because the question said M is held in place, it's not moving. Okay, he gave a suggestion at the end. He said draw a free body diagram for each pulley. بدي نبه على شغلة أول شيء إنه هيدا السترينج it's the same string. هيدا this one هو turns on the first pulley and then it goes round and turns on the second pulley. It's the same string. هلا هيدا السترينج اللي فوق هيدا هون هيدا same string عندي شقفة، وهون عندي شقفة ثالثة. so أنا عندي 3 شقفات من السترينج. remember that same string same tension هيدا بيكون صحيح لما يكونوا البوليز massless. okay, so here T1 it's equal to T2 it's equal to T3 it's equal to the same tension. Why? Because it's the same string. So let me write here, this is part A. We have T1 equals T2 it's equal to T3 it's equal to F. okay, these are tensions T1 T2 and T3 لقيناهم in terms of F. بيبقى عندي أنا T4 and T5. look at T4. I will draw the forces acting on the large pulley. What are the forces acting on the large pulley? I will draw them aside كرمال تصير الرسم مبينة. so عندي T4 upward, this is T4. عندي downward T1. عندي downward T2 وعندي هون downward T3. so this large pulley is at rest, so I will apply Newton's first law. apply Newton's first law. so sum F external on this large pulley is equal to 0. We have 4 forces T1, T2, T3 and T4. Let's project along vertical, projection along the vertical. I will write them first. T1 plus T2 plus T3 plus T4 is equal to 0. projection along the vertical. These are at rest, so ما بهم إذا أنا أخذت positive sense upward or downward ما رح يفرق شيء. projection along vertical. so I will get T4 minus T1 minus T2 minus T3 it's equal to 0. We all know that T1 equals T2 equals T3 equals F, so T4 it's equal to 3F. وهيك بنكون جبنا ال T4. يبقى معي بدي اجيب انا جبنا T4 كنا قبل جايبين T1 T2 T3. ما بدي اجيب ال T5. I will study now the pulley that is the small one. The small pulley في عليها T2 upward the factor, T4 T3 sorry upward and the T5 downward. دايما السترينج بشد لعنده. Okay, these are vectors. So كمان let's apply Newton's first law for this pulley. Sum لل F external is equal to 0. So we will get T2 plus T3 plus T5 it's equal to 0. I will project along the vertical. I get T2 plus T3 minus T5. T5 is downward is equal to 0. So T5 it's equal to 2F. T2 is equal to F. T3 it's equal to F. So T5 it's equal to 2F. هيك بنكون لقينا T5. Okay. In part B بيقول لي find the magnitude of F. بدي اجيب ال magnitude of F. بطلع انا على ال M اللي هو ال object M. Let's apply Newton's first law for M. So M is at rest. Let me write here. So part B, M is at rest. What are the forces acting on object M? في عندي ال weight اللي هو mg. في عندي ال tension اللي هي T5. So sum of forces acting on M are 0. So sum of F external it's equal to 0 implies TS plus mg it's equal to 0. Projecting along the vertical T5 minus mg is equal to 0. So T5 it's equal to mg. نحن كنا جايبين T5 it's 2F. So بيطلع معي 2F implies 2F equals mg and we get F equals mg over 2. Okay, I will mark it with yellow. هيك بيكون خلص السؤال. I will add a part. هيدا البارت من عندي أنا. بقلنا this is part C. بقلنا if a mass M is attached to the string instead of holding it with a force F. هيدا الام is enough انه يخلي البولي تمشي يعني it moves downward and the pulleys and the small pulley will move upward. So بهيدي الحالة بقلنا find the acceleration. I will move down. Find I will call it here, I will call it small m لأنه نحن كان هيداك big m so it's small m. Find the acceleration of big M. We have to find the acceleration of big M. رح أرجع للرسمة لفوق. I will explain what I'm going to do. Okay. هون محل الهاند we are going to attach a mass M large enough بشكل okay إنه M small m will move downward plus and big M will move upward. okay so رح تصير نشد بتطلع البولي مع الام الكبيرة لفوق بينما this M will move downward. okay بقول لي find the acceleration of big M. I have to find the acceleration of big M. To find the acceleration of big M بدي ننبه لشغلة كتير مهمة إنه if M big M and the pulley moves upward a distance x لما يطلع هيدا المسافة distance x الحبل بيرخي من الجهتين مسافة x. So بهيدي الحالة m small m will move downward a distance to x. I will repeat again. When the large mass m moves upward a distance x, الحبل بيرخي من الجهتين x ب x. اوكي so هيدول بيشدون الام m will move a distance to x. so إذا الام الكبير عنده acceleration a, الام الصغير رح يكون عنده acceleration to a. so this will move up x, this will move down to x. okay so the acceleration for big M is a, while the acceleration for small m is 2a. I move down. Okay, let us now apply Newton's, this is in motion, I will apply Newton's second law for small mass m. This is part C. If mass m is attached, then I will write first no annual acceleration. So if mass m and pulley P, this is the pulley P, I will move upward. Okay, this is the pulley P. It can move. So if mass m and pulley P move upward a distance x, mass m will move downward a distance 2x. هيدا بيعني انه if m has an acceleration a, then small m will have an acceleration 2a. Let's first apply Newton's second law for system m. For system m, apply Newton's second law. كان عندي إذا بعدكم ذاكرين كان عندي T5 upward وكان عندي الام جي downward. رح أرجع أذكركم بالام 5 بالام سوري. عندي tension T5 upward كانت وعندي الويت downward وقلنا انه هلا رح تمشي هي upward, it will move upward. So I will say plus T5 minus mg, it's equal to ma, big ma. Okay, ولا هي الاكسلريشن for m. Now T5 it's equal to mg plus ma. خلصت من ال working on m. Let's check the pulley. بالنسبة للبولي كان عندي هيدي البولي which is above the small pulley P which is above M. كانت هيدي البولي في عندي هون tension T وهون في عندي tension T. تذكروا they are equal اللي هني كانوا T2 and T3. T2 and T3 are equal. Okay, this is T2 and T3 and we have T5 downward. هيدي البولي is massless. بما انه هي massless so sum of forces acting on this pulley is equal to 0. Remember that. So for pulley P اللي أنا سميتها P, let us check. apply sum لل F is equal to 0. Then we will get عندي T2 لفوق وعندي plus T3 لفوق minus T5 downward is equal to 0. هلا بالنسبة لنا T2 and T3 are equal لأنه هن belong to the same string اللي كان لونه pink. So T2 it's equal to T3 it's equal to T1 بكل السؤال. So T1 equals T2 equals T3 in all the equation I will call it T. We will get here 2T minus T5 is equal to 0. already T5 أنا جبتها بيطلع معي إنه tension equals T5 over 2 equals T5 جبتها من فوق. This is equation 1. I will use equation 1 to get mg plus ma over 2. This is the tension. هلا شو عم بعمل أنا؟ عم حاول use the information إنه حاول أربطهم ببعض كرمال أخلص من التنشن وآخر شيء لاقي الأكسلريشن. Let's now apply Newton's second law for system M. For system M, with small m that I have attached, I will apply Newton's second law. Sum F external, it's equal to m times the acceleration of this system. هيدي الاكسلريشن هي منا a، هي فعليا هي 2a. Okay, it's 2a, it's not a, or you can call it a prime if you like. We call it a prime because it's a different acceleration, ma prime. So what are the forces that were acting on small m? كان عندي الويت تاعوله mg، وكان عندي t1. ما تنسوا انه t1 بتساوي t2 بتساوي t3 because it belongs to the same string. So انا t already جايبيتها. I will apply Newton's second law. رح يطلع عندي motion is downward. ما تنسوا كل شيء لتحت بيكون plus لفوق بيكون minus. So mg minus t1 equals m a prime implies mg minus t1 جبناها اللي هي mg plus ma over 2 equals m. I will replace a prime with 2a because the acceleration a prime of small m is equal to twice that of large m. It's 2a. راح أضرب كل الإيكويشن ب 2. I will get 2mg minus mg minus ma equals 4ma. I will arrange a to one side وبقسم بيطلع معي بالآخر. I will write it directly. a is equal to 2mg minus mg over m plus 4m. This is the final answer. My numbers I can substitute for them. If I don't have numbers, I will keep it like this. I will move to problem 61, page 147. What horizontal force must be applied to a cart shown in figure P5.61 in order that the blocks remain stationary relative to the cart? Assume all surfaces, wheels and pulley are frictionless. Hint, note that the force exerted by the string accelerates m1. What shall I do? كل مرة بيكون عندي problem في بقلبه pulley أنا I advise you to take each block alone. It's safer for a solution and it's easier. I will start to apply a Newton's second law for each block alone, and then I will try to merge the equations in order finally to find F. رح بلش أول شيء بالسيستم M1. بالنسبة للسيستم M1, what are the forces acting on M1? I have weight, which is, I will draw M1 here. This is M1, it's the weight, it's M1G. وفي عندي normal force, so let's call it إذا بدي F أو N اللي بدي إياه, I will call it N. So it's N exerted by big M on M1. This is the normal of big M on M1 because M is carrying M1. So these are the forces acting on M1. وفي عندي كمان force ثالث اللي هي عبارة عن tension. So this is the tension. صار عندي 3 forces. I will redraw them aside كرمال ما تصير الصورة كتير معجة. So consider system M1. Forces acting on M1 are the weight, M1G, normal exerted by M on M1, and we have the tension for sure. Okay, so these are the forces acting on it. بما انه انا عندي هون الام1 ماشي مع الام كلهم مع بعض ماشيين سوا بشكل انه الام1 ما عم تزحط على الام, it's at rest. Okay, so the acceleration للsmall m or m1 is the same as the acceleration of m. It's similar to شخص قاعد in a bus or in a car. The acceleration of the person is the same as the acceleration of the car because the person is not moving with respect to the car. So with respect to the ground, both have the same acceleration. بالنسبة لي أنا, block M1 is moving to the right with an acceleration A, which is the same as the acceleration of M. So sum F external, it's equal to M1A. The motion is along x-axis, so everything along x-axis will be equal to M1A, along y-axis will be equal to 0. I will use projecting along x-axis and along y-axis. At x-axis عندي t, this is equal to M1A. ما في motion along y, so everything along y will be equal to 0. I won't need projection along y because there is no friction. لو في كان friction, I guess I will need projection along y, but I will project anyway. Minus M1G is equal to 0. So لقيت التنشن بالstring. Let's now move to system M2. So system M2. بالنسبة للM2, I will drive forces acting on M2. This is M2. This is M1. اوكي, على M2 شو في عندي أنا forces؟ في عندي tension. Tension is upward. هيدي التنشن هي نفس التنشن that was applied on M1. ليه؟ Because our pulley is massless and the string is inextensible for sure and massless. So tension هيدي هي ذات التنشن اللي فوق. It has the magnitude M1A. And we have also the weight, which is M2G. كمان ال M2 is in contact with M, so there's a force of contact between M and M2. I will call it F. You can call it whatever you like, but I'll call it F. Okay, force exerted by big M on M2. These are the forces acting on M2. هلا ال M2 كيف ماشي؟ ال M2 هو بالنسبة للM هو at rest بالنسبة للM, بس السيستم كله ماشي مع بعضه بأكسلريشن A. So كمان ال M2 it's moving along x-axis. Everything along x-axis will be equal to MA. Everything along y-axis will be equal to 0. So sum of forces equals MA and the T plus force exerted by M on M2 plus M2G, it's equal to M2A. Let's project now. مين معي على x axis؟ في عندي plus F force exerted by M on M2. This is equal to M2A. مين في عندي على y axis؟ في عندي tension upward، في عندي downward minus M2G. These are equal to 0 لأنه ال M2 is not moving along y axis, it's moving along x axis مع البلوك كلها. اوكي؟ هلا previously أنا كان معي التنشن. The tension was equal to M1A. I will use this equation. I will call it equation 1. I will use this equation 1. هستعمل 1. راح أعوض محل التنشن. I can see clearly that M1A minus M2G it's equal to 0, which gives me A it's equal to M2G over M1. وهيك بصير عندي الاكسلريشن للسيستم أنا صرت عارفيتها. So لما تكون الاكسلريشن equals M2G على M1 أنا بعتبر إنه blocks M1 and M2 are not sliding on the big block M. أنا بشتغل بالبروبلم على أساس إنه هن ما عم يزحطوا لحتى لاقي الكونديشن اللي حتى ما يزحطوا فيه. Okay, so this is the acceleration M2G over M1. هلا أنا مش مطلوب مني لاقي الاكسلريشن، مطلوب مني لاقي الF اللي هي the force exerted on block M so that blocks M1 and M2 do not slide or remain stationary with respect to big M. Let's now use equation, this equation 2. I will call this equation 2 and I will use it later, so let me keep it in mind. This is equation 2. هلا صار معي الاكسلريشن، صرت بقدر الاقي الفورس exerted by M on M2. إذا لقيت equation exerted by M on M2, so I can use it when I apply Newton's second law on the, let's say, the car M. So from 2 I can find that F exerted by M on M2 it's equal to M2A, I will substitute for A, it's M2 squared G over M1. هلا هيك بكون صار معي force exerted by M on M2. Now let's consider the system which is the car. Consider system M. بالنسبة للسيستم M, this is the system M. What are the forces acting on the system? There are plenty of forces. في عندي الفورس F اللي أنا عم بتفش فيها. في عندي الفورس exerted فيني سميه الN. N exerted by M1 on M لأنه M1 قاعد على M. So it's the force exerted by M1 on M. في عندي كمان من الجهة اللي هون في عندي M2 is beside M. So I have the force exerted by M2 on M. Okay, for the naming you can call it N. It's okay for F. M2 on M, it's N or F. Anyway, you can call it whatever you like. It's just a force of contact between each of them. بس أنا معود لما يكونوا adjacent بسميها F. When they are on the top of each other, I call it N. We have the weight, which is mg. وفي عندي أكيد normal from the earth, N, which is upward. This is the normal of the car. هلا أنا ما بهمني ال projection along vertical. أنا بس بهمني ال projection along the horizontal. So I will only project along the horizontal. So let's apply Newton's second law. sum لل F external equals MA. لاحظوا استعملت نفس ال A بكل ال parts because the three blocks have the same acceleration. لو كان أنا عندي حالة إنه for example block M1 كانت عم تمشي بالنسبة لل M, so بسمي سرعة ال M1 بسميها A1, ال acceleration of M بسميها A2. I call them different A's. These different A's must be given during during solving the problem. So let me complete. I will get these all forces. Let's project directly. Projection along x-axis or projection along direction of motion. Along direction of motion. We will get أنا ال positive sense عندي هيك. So plus F في عندي minus the force exerted by M2 over M. اوكي ما في شي غيرهم لهدول الباقيين هني vertical ما خصني فيهم. It's equal to MA. هيدي الفورس exerted by M2 على M هي نفس الفورس exerted by M on M2 according to Newton's third law. لأنه نحن قلنا they exert forces of same magnitude opposite direction. So أنا already لقيت القيمة تاعيلتها. Here it is. It's up. It's colored in yellow. So I will substitute for this force to get. This is F. It's equal to M2 squared G over M1 plus M. I will substitute for A. A was M2G over M1. وهيك بيكون طلع معنا the final answer. I'll move to the last one I'm going to solve, which is problem 34, page 143. I will solve it quickly. In this problem, we have an object of mass M1 on a frictionless horizontal table is connected to an object of mass M2 through a very light pulley P1 and a light fixed pulley P2 as shown in figure 5.34. If A1 and A2 are the accelerations of M1 and M2 respectively, what is the relation between these accelerations? Express. So لما ال M2 يقطع مسافة X downward, okay, it will pull the pulley P1 مسافة X. لما ال pulley P1 تمشي مسافة X راح ينشد هيدا الخيط مسافة X من فوق مسافة X من تحت. So the block M will move a distance to X. So إذا ال M2 عندها acceleration A, M1 will have an acceleration 2A. So M2 has an acceleration A or A2 equals A. So we get M1 with an acceleration A1 equals 2A or 2A2. This is the relation between A1 and A2. A1 equals to A2. So this is part A. Part B says the tensions and the strings, so we have to find the tensions. In order to find the tensions, I'm going to apply Newton's second law for each object alone, and مثل العادي I get rid of tensions, or now I will get rid of accelerations to find the tensions. Then I will substitute for the tensions to find the accelerations for part C. So what I will do, I will start first with object M1. I will consider system M1. Consider system M1. What are the forces acting on M1? We have the tension, which is T1. We have the weight, which is M1G, and we have the normal. بدي بس أكد على شغلة كتير مهمة، إنه same string same tension. أنا رح ألون هون باللون الأحمر هيدا string، هيدا أول string. أنا عندي هون 2 strings، وأنا عندي another string. I will color it with violet. So this is the second string. هدول السترينجز فيهم نفس التنشنز، يعني رح ارجع انا امحي وفرجيكم شو قصدي. هون التنشن، بس انا بدي اسمي التنشن تاعت الام1 بسميها T1. التنشن على البولي P1 من جهة الشمال كمان T1 because it's still the same string. على P2 من جهة P2 التنشن بالسترينج اسمها T2. So all the string has the same tension everywhere. So هيدا T1, it's the same T1 applied to the pulley from the left side. I will re-explain it when I arrive to it, but anyway, this is T1. Let's apply Newton's second law. Sum لل F equals MA. I have 3 forces. It's T1 plus N plus M1G. It's equal to M1A1. I have to precise it's A1. I will project along direction of motion because no need to project along y-axis. Projection along direction of motion. I will get في عندي مع ال positive sense ما تنسوا it's moving to the right. The positive sense is to the right. So I will get T1 equals M1 A1. Okay, this is the first equation. Now let's work on the pulley. هيدي البولي. بالنسبة للبولي في 3 strings attached to the pulley أو 3 parts of strings attached to the pulley. من هيدي الجهة هون هيدي التنشن اللي هو مسميها T1 لأنه هي نفس السترينج اللي كان attached للM1. ومن الجهة الفوقانية كمان بسميها T1 because it's still the same string اللي أنا لونته من شوي بالأحمر. Okay, it's always called the same tension لأنه massless string inextensible string and the pulley is massless. Same string same tension. بينما من الجهة الثانية من البولي رح سمي التنشن T2 لأنه هون string تاني مختلف عن الstring اللي كان موجود from the left side. From the right side there is a different string. So I will call it T2. Because the pulley is massless, so the mass تاعو للبولي is 0. Sum of forces acting on the pulley is 0. So consider pulley P1. Sum of forces on the pulley is equal to 0 because it's massless. So I move down. I have T1 plus T1 plus T2. It's equal to 0. I will project along x-axis. I will get T2 minus 2T1. It's equal to 0 implies T2 equals 2T1. Already I have found T1 it's equal to M1A1. هلا بدي اشتغل على الM2. إذا حدا جرب يشتغل على P2 رح يلاقي إنه ما بتعطيني نتيجة. It will give me T2 equals T2. It gives me nothing. So I will work on M2. بالنسبة للM2, what are the forces on M2? Remember that M2 is going downward, so the positive sense is downward. في عندي weight is acting on it, it's M2G. وفي عندي upward the tension هيدي بسميها T2 نفس التنشن T2 اللي كانت from the right side of the pulley. ليه؟ لأنه it's the same string. So consider system M2. I will apply Newton's second law. I will get T2 plus M2G, it's equal to M2A2. Because they have different accelerations, I call them A1 and A2. And the positive sense downwards, so project along the vertical or along the direction of motion. M2G minus T2 equals M2A2. هلا أنا مطلوب مني لاقي tensions قبل. So to find the tensions I'll try to get rid of the tension I'll try to get rid of the acceleration يبقى مع التنشن. شو راح أعمل؟ راح أجيب ال T2. I will call them 1 2 3 my equations. This is equation 1, this is equation 2 and this is equation 3. راح أحاول أعوض محل ال accelerations tensions, okay, to get only equations with tensions. So let's take this equation. Now I'll try to get rid of the acceleration and form an equation only for t لأنه هو طالب مني لاقي t قبل. So what I'll do, I will take equation 3 implies m2g. راح أحاول أخلص من acceleration t2 equals m2. What's the relation between a1 and a2؟ كنا نحن لاقيين قبل إنه a1 equals to a2. So a2 it's equal to a1 over 2. I will substitute for a1 مثل ما شايفين a1 from equation 1 it will give me t1 over m, it's equal to m2 t1 over 2 m1. It's a1 it's t1 over m1. هلا I will multiply all the equation by 2m1. I will get 2m1 m2 g minus 2m1 t1 equals m2 t1. So this is t2. What I'm going to do now is استعمل one variable اللي هو t1 أو t2. I will substitute for t2 with 2t1. I will get 2m1 m2 g minus 2m1 هيدا رح أحط مطرحها 2t1 equals m2 t1. جمعت t1 على جهة واحدة. شو عملت أنا؟ حاولت خلصت من ال a1 أول شيء بقي معي t1. خلصت من الاكسلريشن بقي معي tensions وأصلا في علاقة ما بين التنشنز اللي هي t1 و t2. استعملت الايكويشن 2 وهلا بجمع صار معي equation فيها بس t1. جمعت t1 على نفس الجهة بيطلع معي 2m1 m2 g minus 4m1 t1 equals m2 t1. So let me take them to the other side. I will write directly the answer. It's clear. T1 equals 2m1 m2g over 4m1 plus m2. هيك بكون جبت ال T1. بدي اجيب ال T2. Remember there's a relation between T1 and T2. T2 equals 2T1. So T2 equals 2T1. It's equal to 4m1 m2g over 4m1 plus m2. Okay, so my tensions. Now in the second part he's asking for the acceleration. فيني نطبق واحد من الايكويشنز اللي انا معي اياهم. Remember that I have three equations. أنا بدي أجيب ال A1. ال A1 it's equal to T1 over M1. Let me use this one. So using equation 1 we get that A1 is equal to T1 over M1. وأنا مع T1 I will only divide by M1. So I will get A1 equals 2 M2 G over 4 M1 plus M2. This is A1. إذا بدو ال A2 already في relation between A1 and A2 which was found earlier. Okay, here it is. It is A1 equals 2 A2. So A2 equals A1 over 2. We will get m2g over 4 m1 plus m2. And this is the answer for part C. And like this, we finish our problem.